In this video, we will talk about recursion. So, recursion is a technique or when we declare any function as a recursive function, then it means that that function call itself. For example, if we have a larger problem uh, and we divide that problem into a smaller problem and we recall that function. What I want to say is that let's say we want to print a number from 1 to 10. Okay, and now we have a function called print number. Print num is a function which is having the argument as int n. Okay, and its return type is void. So what we will do, we will print n, or when we talk about C++, then we will see out n, and then we will decrement the n by 1, and we recall that function print num with a new n. Now our n is decremented by n 1, so we will pass the new n, and that's it. And one more thing is, in recursive function we also have the base condition, because we want to tell the compiler that when we want to stop calling itself. So we have to provide the base condition also. So base condition for this is, when we will reach to the 10, then we do not want to go further. So whenever n becomes uh, yeah, if we want to print the number from, let's change the question. We want to print the number from 10 to 1. Okay, so when we will reach to the 1, then we do not want to go down further. So we will check if n is equals to 1, then we simply see out n and simply return. We will not call again any other function. Okay, so we will not touch this part of the code. We will return from itself here itself. Okay, so why recursion is used? First of all, recursive code is smaller than iterative code. Smaller than iterative code, and it is easy to write for program. Recursive code is easier to write than iterative code. Okay, and we do not need to go and it's become simple. It is simple. Okay, but the we have also disadvantage of the recursive function. Disadvantage will be, first of all, it will take the extra space in a stack memory. It takes extra stack space each time when we call function. Okay, this is the main disadvantage of this recursive code, because in the backend what generally happen is, let's say we are calling a parent name function with passing number 10. So in our memory this program, this program will load. Okay, this program will load, and first of all, it will check if n is small is equals to 1. It is not. It will read line by line. So 1, 2, 3, 4, 5, 6, 7, 8. So it will run line by line, and at the line number 8, it will find that there is another print num function with uh, n is equals to 9, because we have decremented n by 1. So what it will do, CPU will this context, OS will save this context, and in the memory again another function will be loaded with the same code will be loaded again. Okay, but here n was 10, but here n will be 9, and, and in this way many number of times the code will be loaded into the memory, and at last when n will be 1. Okay, when n will be 1, then what it will do, it will check that n is equals to 1, so it will simply see out n and simply return from it. So when it will return, so it now this function, the task of this function is completed. It printed n, so it will return the control to this function which has called this function. So here n was 2. When n was 2, this function called this function, so the control will passes to this function. So when the function was called at the line number 8, at the line number 8, now it's when eighth line was occurred in when n was 2, so it has saved, this context has been saved in the memory, and then this function has been called. This function has been called. Now this code has completed its task. Then the control will return to the eighth line. Then eighth line terminated, and now ninth line will be terminated, and then again the control is passed to n is equals to 3, and so on it will goes on until uh, the control is not get to the n is equals to 10 function that is having the n is equals to 10. So there is lot of context switching. Context switching means we have this is the context, the whatever the detail of the program is called the context, whatever the value of the variables or whatever the resources the code has opened during the execution of the program, the then the detail of all this is called the context. It is all the saved in the memory. So the all the detail is saved, and then again when the function call is occur, then again another function is called in memory. It takes another, if this is taking order of k space, then again order of k space will be required in the memory to load another function, and then again this function will call another function, so on. And this is called the context switching, switching from the one program context to the another program context. And when this program will be terminated, then the control is then again returned back to its previous function, then again context switching happen. So it is a very heavy task, and it takes us time. It takes also the time also, and uh, also take the extra space in a memory. So that is why recursive function is smaller. Generally recursive functions generally slower than iterative function. This is also the disadvantage of the recursive function because lots of things going on in the backend when we use the recursive function. So that is why recursive function are slower than the iterative function. And we use the iterative function in many algorithms, and that we will discuss in the next lecture. So that's why I taught you the recursion, that what is recursion, so that you can familiar with the recursion. In the next video we will discuss the algorithm in which we will use the recursive function. So uh, let's move to the next lecture.